All right, everybody. So today's video will be talking about just one topic, and that's solving, I guess you could say, radical equations that are a little more complicated than the ones that we've already seen. Okay, so rough title, working title for the video, Solving Radical Equations Part 2. So let's talk a little bit about terminology. I don't feel like it's right to just make a video that only shows you the steps. You can skip to that part if you want to, right? Watch it however you want. I feel like it'd be the right thing for me to do to tell you a little bit about the terminology and, make some introductions to how we're going to do things. So when I say that these are radical equations, what I mean by that is the way we use the word in math is that any kind of a root is a radical. Like if I say square root of 16, that square root is a radical. Or if I say the fifth root of 32, that fifth root is also a radical. And then we could go figure these out if we wanted to. Square root of 16 is 4, right? Why is that? Because 4 squared is 16. That's the reason. Okay. And fifth root of 32 is 2. So why is that? Well, there's a reason for that, like there's a reason for everything. 2 to the fifth power is 32. Right? There's the circular proof for roots. If 2 is the answer, then 2 raised to that power should give you 32. If you don't believe me, then try it out. Say, well, what's 2 times 2 times 2 times 2 times 2? Do the math. It's 32, okay? All right. So I wrote those down just to tell you that's what radicals are, but I thought, I'll go ahead and answer them so that we're clear on how you do that too. Now, next thing I want you to think about is what would happen if we square a square root, okay? So let's try it out and see. So what if I took like the square root of 16 and I squared that? Or what if I took the square root of 25 and I squared that? Ultimately, what would happen? Well, let's work this out. I'm not going to just tell you. I'll tell you in a minute. I want you to see it, okay? So square root of 16 squared. Well, there's an order of operations. Like there's an order we do things. We work inside the parentheses first. What's square root of 16? Well, that would be 4. And then what is 4 squared? Well, that would be 16. Maybe you see a pattern. Let's try this one. What's the square root of 25 squared? Well, the working inside the parentheses square root of 25 is 5. And then 5 squared is 25. So do we see a pattern? I think I see a pattern. If you square a square root, it's like they cancel, right? It's like the squaring and the root canceled and you just got 16. The squaring and the root canceled and you just got 25. So we can say if you took the square root of some number n, as long as that number is a positive number, and you squared it, well, you're just going to get that number in whatever it is, okay? So let's just take this as an assumption from now on. But you could work it out. You have a way to understand it. You don't just have to take my word for it, okay? All right, now let's do our first question. Let's try to solve this one. Now, the whole technique to solving this is going to be through squaring both sides of the equation. When we solve an equation, if I want to do something to one side, I need to do it to the other side. So why is that? Well, you see the equal sign? It means that the two sides are the same. And you want to keep them the same. That means what you do to one side, you have to do to the other. Okay? So because of the presence of roots or radicals, I'm going to be squaring both sides because what do we say happens? Well, when you square a root, it will cancel. It won't be there anymore. And wouldn't this equation appear a lot easier if it didn't have the roots in it? I think so. So I think, if we can get rid of them somehow, we will. Now, the way that we want to do this is to isolate one of the roots on one side of the equation. So like for our purposes here, let's say if I only had that one by itself, it would be better, okay? So I'm going to add this other one to both sides, okay? Because again, what I do to one side, I do to the other. I want to add root x minus 8 because I want to cancel this one. I want to isolate that one. So when I apply the square to it, it will directly cancel the root. I'll have to worry about this other one later, okay? So that's where we'll start. And if I do that, then here's what I get. I get root x plus 12 all by itself on the left-hand side because these cancel. And then I'll get, well, I can't really add 2 in root x minus 8, so I'll just have a root x minus 8, but then also a plus 2, right? Because that was positive, so plus. So I'll get here. Now I will square both sides, okay? I'll square the left because that will get me a little bit closer to my goal of canceling all the roots. So why is that? Well, because, you know, we just talked about it, didn't we? If you square a square root, it will cancel. So I get x plus 12. But what about this side? How do you square that? Like, see, the other side has more stuff on it. So how do you square it? Well, so let me show you. I went ahead and I wrote this out separately. Okay? So here's what we're going to do now. Say root x minus 8 plus 2 all squared. Okay, well, what does it mean to square something? Multiply it by itself. Okay? So there it is. Like what's 4 squared? Well, it means 4 times 4, right? So root x minus 8 plus 2 squared means root x minus 8 plus 2 times root x minus 8 plus 2. That's just what squaring means. Well, then how do you do that? Well, we have a technique for that, FOIL multiplication. So let's try it out. Root x minus 8 times root x minus 8. Well, that's like squaring a square root. We'll cancel the square root. So we'll get x minus 8. Then we'll get 2 times root x minus 8. Then we'll get 2 times root x minus 8. Then we'll get 2 times 2, 4. First, outside, inside, last. Can you do anything with that? Well, there are some like terms. These two terms are like terms. Well, it's 2 apples plus 2 apples. It's 4 apples. What's 2 root x minus 8 plus 2 more root x minus 8? 4 root x minus 8. Okay, so we add those together. Anything else? I got negative 8, 4. What's negative 8 and 4? What's the grand total there? Negative 4. All right. So that's how you take care of that. It's somewhat complicated, right? But that's math. That's what you do. So that's what my right-hand side is going to be. You see over here, I take root x minus 8 plus 2 squared. Here's what I get when I work all that out. I get like so, okay? Now let's combine terms, like maybe do like this. You know how I isolated this root right here? So when I square that, I can directly cancel. I think we need to do the same thing again. So suppose like I subtract the x from both sides. And suppose I add 4 to both sides. Okay? So if I subtract x from both sides, it's going to cancel. Minus x, minus x. If I add 4 to both sides, I'm going to get 16, right? Add 4, 12 plus 4, 16. And I'm going to get like this. Okay? All right, we're almost there. That root's almost isolated. See, first I started off isolating this one. Then I applied the square to both sides. I've almost isolated that one. Why do I say almost? Because the 4, well, what can you do with the 4? How's the 4 stuck to this other thing? Does that say 4 plus? Does it say 4 minus? What's the 4 doing? It's multiplying. So what if you divide both sides by 4? You cancel it over here and introduce it like that over there. And then we're getting a little bit closer. 16 divided by 4 is 4. All right, then we're like that. And then one more step. If I move the 8 over, I'll get 12, right? Say I add 8 to both sides. I get 12 is equal to x. Or if you'd rather say x is equal to 12, same thing, right? So it appears we have our answer. Now, let me just say for now, without explaining, that whenever you square both sides of the equation, oh my goodness, I can't believe you probably noticed this. Okay. So when I divided by that 4, it did not make the root go away. Okay. All right. So I divide by the 4, I get 16 over 4 is 4, and that's root x. Okay, so now we'll square both sides again. Like that. Okay. And then I'll get 16 and x minus 8. Okay. So I square the left-hand side, 4 squared 16. And then here I had root x minus 8, which I'm also squaring, which directly cancels, leaving me x minus 8. Okay, and then I'll add 8 to both sides, and I'll get 24, right? 16 plus 8 on the left, canceling the 8 on the right is equal to x. So I could say x is equal to 24, or if you would prefer, reading it this way, like that, right? 24 is equal to x, or x is equal to 24. Same thing, 24 looks to be our answer, okay? Now, so this part, I'll just say it without explaining it, okay? And that's whenever you square both sides of an equation, which I did in 2 separate steps, all right? Then I have to check my answer. That's just the nature of it, okay? I'll explain why later. For now, I'll just say that that's a necessary part of this. So I'll put down here that checking the answer is essential, okay? In other words, 24, even if I did everything right, here I made a mistake, but I caught it, but even if I did everything right, might not actually work. That's just the nature of the problem when you square both sides of the equation, whether you do it once or twice. So must check where? Well, what were we trying to solve? We're trying to solve this one. This is the one I'm trying to answer. I'm trying to find the number that if you plug it in right there, it actually works, okay? I'm not trying to solve this one. I'm not trying to solve this. I'm not trying to solve any of these except for the one I started with. So that's the one I'm checking it in. So let's take 24, our supposed answer, and plug it in up there and see if it works, okay? So say I plug in the 24 for the x. I'll get 24 plus 12, right? And then minus 24 minus 8. And then equals 2. And this may or may not work. So I'm putting a question mark. Is it going to equal 2 or not? That's for me to decide right now. But what you're looking at here is just checking this proposed answer up there, putting it in place of the x. Okay, well, what's this going to be? That's going to be root 36. Okay, and what's this going to be? That's going to be root 16. And is it 2? Well, what's root 36? That would be 6. What's root 16? That would be 4. And then it just comes down to, is 6 minus 4 equal to 2? And yes, 6 minus 4 is equal to 2. So 24 works. I would commit to that answer at this point. Okay? But, I didn't know whether it would work or not until I checked it, even if I did everything right. Okay. So, let's do a quick summary. So we take our equation. I'm going to isolate one of the roots. I'll square both sides because it will cancel that root. Then I'll isolate the other one that's left over, and I'll square both sides again, and it will cancel that one. Then there won't be any more roots, and I can just do things like add 16 and 8 to get the final answer. All right. Okay, and then I have to check it, of course. I'll explain more about the checking it later, but you just plug the number in and you see if it works. Okay? All right, let's try another one. Let's try this one. Okay, it looks similar, but I think there's a few things in it that are going to work out differently. Now, what I notice about this one is it's already written so that that root is isolated. So here's what I think I'll do. I don't think I'll do anything to it as far as rearranging it, meaning I don't want to move this thing over there, or I don't want to move the 1, or I already have that root x by itself. It's already isolated. So if I were to square both sides as it is, then I could at least cancel that root and I would be a little bit closer to where I want to be. So, right, what's, say I squared both sides. Okay, what's the square root of x squared? Well, they cancel each other. Square roots and squares cancel, so you're just going to get x. What is 1 minus root x minus 5 squared? Well, that's something kind of like that last problem. So I went ahead and I wrote it out separately so we could just focus on this. But if you took 1 minus root x minus 5 squared, again, what does squaring mean? What does 5 squared mean? It means take 5 times 5. That's what it means. So I need to, if I'm going to square this, whatever that is, I need to take it and multiply by itself. And then how do you do that? FOIL multiplication. 1 times 1 is 1. 1 times negative root x minus 5 is negative root x minus 5. Negative root x minus 5 times 1 is negative root x minus 5. And what's negative root x minus 5 times negative root x minus 5? Well, a negative times a negative is plus. But then root x minus 5 times itself, well, that's like squaring it. And squares do cancel roots, so you'll just get x minus 5. And then is there anything we can combine? These are like terms. Negative 1 root x minus 5 minus 1 root x minus 5. That would be minus 2 root x minus 5. And then I'll get the x. And I have a 1 and a negative 5, which is negative 4. Okay, so that's what I'm going to get applying the square to that right-hand side. Let's write that down and see where we can take it from there. I'll get x minus 4 minus 2 root x minus 5. So from here, I want to get this root by itself. Why? Well, because if I can get it by itself and apply a square to both sides, I'll cancel the root. Ultimately, we just want to cancel the roots. We'll have to rearrange the equation to get them alone in order to square and make that happen, but it's right there. We can get that by itself if we need to. It will work out. Like, what if I subtract x from both sides? So I do minus x and minus x. Well, then that's gone. 0 here, negative 4 minus 2 root x minus 5 over here. What if I add 4 to both sides? Okay, 4 here, negative 2 root x minus 5 there. What about the 2? What are we going to do with the negative 2? Well, again, how is the negative 2 attached to that root? Is that a division, a multiplication, subtraction? It's multiplication. It says negative 2 times root x minus 5. So we will divide both sides by negative 2. And I'll get negative 2 over here because that is 4 divided by negative 2. And then I'll get root x minus 5 over here. Okay, so now I've isolated this other root. And I can solve it by squaring both sides. Okay, all right, so here we go. I square both sides. What's negative 2 squared? What's negative 2 times negative 2? That would be positive 4. And what is root x minus 5 squared? Well, that's the whole reason I got this by itself and applied the square, because I'm going to cancel that root. It's just going to be x minus 5, okay? And then if I add 5 to both sides, I get what appears to be my answer. It says 9 minus x, but we could say x is equal to 9, however you want. X, our answer, appears to be 9. Now, I did say that you have to check these. I did say that whenever you square both sides of an equation, even if you do everything right, it doesn't mean that your answer is going to work. Okay, so we must check. It's not like I can say, well, I was really careful and I know I didn't make a mistake, so I don't have to check. No, squaring both sides can introduce false solutions, so we have to check and make sure that it works. Okay, so let's take 9 and check. We'll check. What are we checking? Well, that was the one that I was trying to solve. I'm trying to figure out what the x needs to be to make this equation work. I'm trying to figure out what the x needs to be to make this true. So I need to plug in 9, which is our supposed answer, in for the x. So if I do that, it will look like this. Root 9 equals 1 minus root 9 minus 5. Okay? Question mark. I don't know that that's going to work. That's what I'm trying to evaluate right now. So let's see. Root 9, well, square root of 9 is 3. And what's 9 minus 5? Well, that'd be 4. Okay. And what is root 4? It's 2. So is that true? Is 3 equal to 1 minus 2? No. That's not true. Okay. Not true. So I did all this work and I got 9. I plugged the 9 in, it didn't work. What does that mean? It means that there's no solution. Okay. So it's not like there's an answer to this problem and I just didn't find it. If there was an answer to this equation, it would have showed up here. And the only number that showed up didn't work. That means there isn't an answer. Okay? So this equation, it's impossible. There's no number anybody can find that if you plug it in will work. Okay? So that happens in science and engineering. Sometimes we can conceive of some problem or some situation and we want it to work a certain way, and then we figure out it's impossible. So that's kind of what this is like. We figure out that what we want to happen can't actually happen. All right? Okay, so there's no solution to this one because if there was a solution, it would have been 9, but we checked the 9 and it didn't work. So there's not one. Okay? Now, let's talk about that a little bit. Let's talk about why we must check and the nature of the checking and the answer that didn't actually work. So the fact of the matter is that if we ever square both sides of an equation, then we must check our answers because those false answers can show up. Okay? So in order to give you some insight to that, I'll make a quick comparison. Take this simple equation. 2x plus 1 is equal to 11. How would you solve that? Well, you'd subtract 1 from both sides. You'd get 2x is equal to 10. Then you'd divide by 2, and you get x is equal to 5. But I want you to notice something about that. 5 works in every single step. It works in the original one I'm trying to solve, but it works in every step along the way. Like, take 5. Is 5 equal to 5? Yes. Is 5 equal to 10 divided by 2? Yes. Is 2 times 5 equal to 10? Yes. Is 2 times 5 then plus 1 equal to 11? Yes, it works all the way. So, like when you solve by subtracting and dividing, you don't have to check your answer. As long as you don't make a mistake, it's guaranteed to work all along the way. But look at this one. Say I take this very basic equation, x is equal to 5. What's the solution to this equation? Well, it's almost too obvious to ask. 5, right? 5 equals 5. The x, that letter needs to be 5. What if I square both sides, though? Something weird happens. I get x squared is equal to 25. Why do I say that that's weird? Well, what can x be to make this equation work? Well, x could be 5, because 5 squared is 25. But it could also be negative 5. Why is that? Negative 5 times negative 5. So negative 5 squared. So negative 5 times negative 5. What's a negative times a negative? It's positive. What's negative 5 times negative 5? 25. So see, this has more answers than that one that came before it. So all I'm trying to prove is if you have an equation like whatever the answer is, and you square both sides, then you have this chance that more numbers will show up that don't actually work in what came before it. Where the idea when we solve equations is that what works here is what works up here. But that's not true when you square both sides. It's not all the time true, at least. At least you can see here, -5 doesn't work up there. Is -5 equal to 5? No, of course not. So you get this number that works down here that doesn't actually work up there. That's why you have to check your answer.